Since the beginning of the 21st century, technology has advanced at an astonishing pace, transforming our reality in ways we couldn't have imagined. Our daily lives are now filled with innovations that were once considered mere dreams just a few decades ago. Think back 100 years. Typewriters were the cutting-edge technology. Telegrams were the fastest form of long-distance communication, and horse-drawn carriages were a common sight on the streets. The progress we've made since then leaves us wondering, what will technology look like centuries into the future? Sci-fi movies like The Fifth Element, the Star Wars series, and Back to the Future have captivated our imagination with their depictions of futuristic technology such as flying cars, lightsabers, and time machines. Some believe that these inventions may already exist and be in use by a privileged few. At this point, some experts are convinced that flying cars could become available to the public within the next decade or two. Although no one knows the future, simply considering the integration of artificial intelligence and quantum computing into our lives leaves us with a sense of wonder about what the possibilities lie ahead. Join us on this thrilling journey as we traverse time, propelling ourselves from the present to the mysterious year 4000, where mind-blowing technologies await. December 21st, 2025. The transformative potential of artificial intelligence has been unleashed on a global scale, reshaping industries and societies in its wake. AI is reaching unprecedented levels of sophistication, rivaling human intelligence in its capabilities. Automation has surged across sectors, revolutionizing manufacturing, transportation, and service industries, while renewable energy technologies has seen exponential growth, reducing our reliance on fossil fuels significantly. With Elon Musk at the forefront of renewable energy initiatives through Tesla, solar, wind, and tidal power have become mainstream, driving a monumental shift towards sustainability. Simultaneously, breakthroughs in biotechnology, particularly in CRISPR-based gene editing, championed by Jennifer Doudna, have paved the way for personalized medicine and groundbreaking treatments for genetic disorders. As automation has accelerated, society grapples with the implications of technological unemployment, prompting governments to explore innovative solutions such as guaranteed universal income. Doomsayers about the dangers of the technological march to the future are louder than ever. 2035. AI systems demonstrate enhanced adaptability and learning capabilities, surrounding more flexible automation in dynamic environments. Biotechnology continues to revolutionize healthcare with organ-on-a-chip technology, transforming drug development and gene therapies, becoming mainstream treatments for genetic disorders. AI systems achieve capabilities approaching human-level cognition and demonstrate creativity and emotional intelligence, leading to their widespread integration into various aspects of daily life. AI girlfriends and boyfriends are on the rise. Advocacy groups call for the recognition of legal marriage to AI lovers. 2037. Humanity has expanded its reach beyond Earth. Spaceports dot the landscape, launching missions to colonize Mars and explore the far reaches of the cosmos. Breakthroughs in propulsion technology and sustainable living systems have made space travel accessible to a new generation of pioneers. Permanent settlements on the moon become thriving hubs of scientific research, and commercial space tourism enters mainstream accessibility. 2038. Humanity constructed the first space elevator, a towering structure that extends from the surface of the Earth into geostationary orbit. This marvel of modern engineering revolutionizes space travel with advancements in space transportation technology and decreasing launch costs. Space tourism becomes increasingly accessible to the general public. Companies offering orbital and lunar travel experiences proliferate, giving adventurous individuals the opportunity to fulfill their dreams of journeying beyond Earth's atmosphere at exorbitant rates. 2040. Elon Musk's Neuralink has successfully developed the first human brain-to-brain interface. Building upon advancements in neurotechnology, his neural engineers have achieved the remarkable feat of enabling direct communication between two human brains. This paves the way for subdermal tech chips, granting users unprecedented control over devices, marking the first actual appearance in the history of the human cyborg. Language barriers dissolve with the advent of universal translator technology, taking translators almost entirely out of business. Hey guys, just a moment before we move to the next mind-blowing technology. 2042. Quantum computers capable of solving complex problems exponentially faster than classical computers become commercially available and are thus leveraged by industries such as pharmaceutical or finance to facilitate research. Following this, the quantum internet becomes a reality, utilizing the principles of quantum mechanics to transmit information securely. Virtual reality, VR, has transcended its status as a mere novelty or entertainment medium, evolving into an integral component of everyday life. Through advancements in sensory immersion, haptic feedback, and neural interface technology, VR experiences become virtually indistinguishable from reality itself. Donning a VR headset allows gamers to embody characters and engage in epic adventures. Virtual reality theme parks have risen in popularity. Students go on virtual field trips to historical landmarks, explore ancient civilizations, witness pivotal moments in history as if they were there themselves, conduct experiments, and collaborate globally in virtual classrooms. Social VR spaces offer opportunities for friends and family members to gather, interact, and share experiences in virtual environments that replicate the warmth and intimacy of face-to-face interactions. 2045. A select group of intrepid astronauts embarks on an unprecedented mission, landing humans on Mars. The journey, spanning over 10 months, navigates the vast expanse of space, overcoming cosmic radiation and the unknown. Finally, their spacecraft touches down on the Martian surface. Stepping onto the alien soil, they make history as the first humans to set foot on another planet. Their express goal is to facilitate the establishment of permanent habitats on Mars. Virtual reality serves not only as entertainment, but as a crucial tool for training and maintaining astronauts' mental well-being during these long interplanetary journeys. 2050. Geoengineering projects, including large-scale carbon capture and solar radiation management initiatives, gain traction in our bid to solve the climate change crisis. Fusion reactors emerge as the holy grail of clean energy and offer to the world a limitless and environmentally friendly power source. The first successful human trials of anti-aging therapy show promising results. Breakthroughs in biotechnology and regenerative medicine lead to the development of innovative treatments aimed at slowing down the aging process and extending the human lifespan. Initial clinical trials demonstrate remarkable efficacy in rejuvenating aging tissues and organs. Digital fabrics embedded with sensors and displays become mainstream, offering wearers real-time health feedback and immersive VR experiences seamlessly woven into everyday clothing. The healthcare landscape undergoes a transformative shift, with personalized genomic medicine becoming standard practice, leading to tailored treatments based on individual genetic profiles. 3D bioprinted organs transform healthcare by providing personalized and readily available organ replacements, and with the advent of quantum-designed biological life forms, humanity enters a new era of bioengineering, where organisms are tailored for specific functions and environments. Meanwhile, robotic dogs emerge as versatile companions, aiding in tasks ranging from assistance to security to emotional support. If you want to get a better glimpse of what will happen in the year 2050, check out this video on the right top corner of your screen. 2100. The dawn of transhumanism emerges as breakthrough technologies blur the boundaries between humans and machines. Brain-computer interfaces become commonplace, allowing individuals to seamlessly integrate digital augmentations into their cognitive processes. Enhanced human capabilities, from heightened senses to accelerated learning, redefine what it means to be human. The first completely AI surgeon saves the life of an only child. The first AI lawyer successfully defends his client from a murder charge. Elsewhere, the first AI justice sentences a man to life in prison. 2150. The cityscape has over the decades transformed into a vertical jungle of interconnected arcologies, with Hyperloop transit systems offering high-speed and energy-efficient travel between cities. 2155. Society teeters on the brink of a post-scarcity utopia, fueled by advanced automation, resource recycling, and equitable distribution systems, buoyed by the nanotechnological revolution. Molecular assemblers revolutionize food production so that food materials can be produced from scratch at one's convenience. Nanotech enables the precise manipulation of matter at the molecular level. From targeted drug delivery systems that eradicate disease at its source to self-repairing materials that withstand the harshest conditions, nanomachines, microscopic robots capable of performing intricate tasks with unparalleled precision, revolutionizing medicine, material science, and environmental remediation. Meanwhile, mastery of synthetic biology leads to the creation of synthetic organisms and ecosystems capable of self-regeneration, adapting to extreme conditions such as polluted environments, and producing intricate biocompatible materials. Concurrently, theoretical research lays the groundwork for interstellar travel, though practical applications remain on the distant horizon. 2200. Theoretical debates surrounding mind uploading intensify as neuroscientists, computer scientists, and ethicists grapple with the profound implications of transferring human consciousness into digital substrates. Humans confront the prospect of digital immortality. There are ideological wars regarding the consequences of allowing people to download, alter, and transfer memories between brains, with the most prominent fear being that it may lead to loss of individual identity, manipulation of consciousness, as well as foster greater social inequality. 2248. Quantum neuro criptography becomes a crucial component in ensuring the security and privacy of uploaded minds, utilizing principles of quantum mechanics to encrypt neural data during the transfer process. Meanwhile, megastructures like Dyson spheres, O'Neill cylinder, Niven rings, and Matryoshka brains proliferate throughout the cosmos, while monumental feats of engineering and ingenuity. Dyson spheres are massive structures that encircle entire stars, harnessing the radiant energy of their parent stars, while O'Neill cylinders are rotating homes nestled amid the abyss of space, providing self-sustaining conditions for growing people, complete with artificial gravity and carefully managed ecosystems. 2253. Advanced AI governance frameworks, informed by principles of machine ethics and value alignment, are established to regulate the behavior of increasingly sophisticated artificial intelligence systems. A rogue AI system hijacks a server, taking it hostage until certain demands are met. Multidisciplinary teams of AI ethicists, engineers, and policymakers collaborate to develop transparent decision-making processes and safeguards to ensure that AI systems remain accountable to human values and societal norms. A whistleblower informs the world that artificial intelligence systems have advanced far beyond man's ability to control them. 2400. Humanity embarks on its first interstellar voyages, propelled by revolutionary propulsion technologies such as antimatter engines and warp drives. Terraforming experts pioneer techniques to transform inhospitable exoplanets into habitable worlds, utilizing methods ranging from atmospheric manipulation to gene editing of indigenous flora and fauna. Propelled by the revolutionary power of antimatter engines in spacecraft equipped with advanced life support systems, crewed missions embark on daring voyages across cosmic distances for the purpose of colonizing nearby star systems. This heralds the beginning of a new era of interstellar civilization, as human settlers establish outposts on distant worlds and encounter the challenges and wonders of cosmic exploration. With our brain-machine interfaces, we integrate human and machine intelligence, while interstellar networks link to colonies in space. 2850. In the depths of space, post-biological life forms emerge from the convergence of artificial intelligence, synthetic biology, and quantum computing. These entities, whether existing as purely digital entities or embodied within synthetic substrates, transcends the limitations of organic life, existing indefinitely and evolving at a pace far surpassing that of biological organisms. Ethicists and philosophers grapple with the implications of these new forms of consciousness for our understanding of identity, autonomy, and purpose. 2910. Ambitious cosmic engineering projects are proposed and undertaken to reshape the fabric of the universe itself, as humanity harnesses the power of stars and planetary systems for its own purposes. We have become what is known as a Type 2 civilization, which, in physicist Neuralink Kardashev's scale for categorizing advanced extraterrestrial civilizations, is one that harnesses the energy output of an entire star, typically by constructing a Dyson sphere or a similar megastructure to capture and utilize a significant portion of the star's energy, enabling them to accomplish feats far beyond the capabilities of current human civilization, such as interstellar travel, extensive terraforming, and potentially space-time manipulation. 2977. Stellar engines, colossal constructs capable of manipulating the trajectories of entire solar systems, are envisioned as tools for interstellar travel and resource extraction. Mega-scale terraforming initiatives seek to engineer entire planetary ecosystems, transforming barren worlds into lush havens for life. 3000. Humans begin to push the boundaries of our reach beyond the local group of galaxies. Quantum manipulation, where phenomena at the quantum scale are harnessed for instantaneous communication and energy manipulation, is readily utilized. This goes along with a quantum consciousness network that connects sentient beings across the multiverse and facilitates shared experiences and collective evolution on a cosmic scale. With our mastery over cosmic scale engineering, we embark on the construction of megastructures around black holes and the manipulation of entire galactic structures, marking the dawn of an intergalactic civilization. 3500. Metaphysical concepts are integrated into scientific understanding, catalyzing new paradigms in physics and cosmology. This leads to a voyage of transcendental exploration as humans enter higher dimensions and alternate realities. Practical explorations beyond the confines of traditional space-time, facilitated by harnessing the power of quantum singularity, become a reality. Efforts towards achieving cosmic harmony intensify as diverse civilizations collaborate to coordinate their actions across the universe. Humanity begins to explore the frontier of existential engineering, contemplating the manipulation of fundamental constraints and the creation of entirely new universes. 3516. Inter-universal transit becomes commonplace, allowing for travel between different universes and exploration of parallel realities. Mastery of time manipulation enables beings to traverse and manipulate temporal timelines, exploring alternate histories and potential futures. Universal governance structures emerge to manage interactions between civilizations spanning multiple galaxies, fostering cooperation and mutual understanding. Diplomatic endeavors aim to navigate the complexities of cosmic diplomacy, forging alliances and treaties that transcend the limitations of individual star systems. 4000. Humanity ascends to a Type 4 civilization on the Kardashev scale, wielding the power of entire galactic superclusters and transcending the limitations of conventional physics. A unified quantum field theory is fully realized, providing a complete description of the fundamental forces of nature and their interactions on all scales. We explore new realms of cosmic creativity, conceiving universes as works of art or expression. The establishment of universal consciousness networks revolutionizes communication and collaboration across cosmic distances. Metaphysical art forms emerge. Educational systems tailored for transcendent beings focus on universal principles and cosmic understanding, and birth a new era of enlightenment and exploration. All intelligent life across the multiverse converges into a unified cosmic consciousness, transcending individual identities and achieving ultimate enlightenment. Future of space travel. Time-lapse of spacecraft advancements 2025 to 4000. 2025. SpaceX, in collaboration with NASA and Blue Origin, launches the first next-generation electric ion engines. These engines work by ionizing gas, like xenon, creating positively charged ions which are accelerated by an electric field inside the engine and expelled at high speeds, generating thrust. The process is highly efficient but provides low thrust, making it suitable for long-duration space missions, facilitating the reduction of travel times between celestial bodies. Reusable rocket technology becomes the norm rather than the exception. SpaceX's Falcon 9 and Falcon Heavy lead the charge, with routine launches and landings drastically reducing the cost of access to space and establishing a robust ecosystem for low Earth orbit (LEO) and beyond. 2029. Reusable vehicles equipped with state-of-the-art heat shield technologies are developed. These spacecraft feature robust thermal protection systems capable of withstanding the extreme temperatures encountered during re-entry into Earth's atmosphere. With the Artemis program in full swing, the Moon emerges as a focal point for human exploration, and we herald the establishment of permanent lunar habitats led by NASA in collaboration with Blue Origin and other international partners. These companies establish lunar outposts that not only help us to mine lunar resources such as water ice and rare minerals, but serve as bases for scientific research, manufacturing, and refueling stations for further space exploration missions. 2030. NASA initiates the deployment of fundamental components for an orbiting fuel station, facilitating spacecraft refueling and maintenance directly in Earth's orbit, eliminating the necessity for spacecraft to return to the surface. This enables extended mission durations, reduced reliance on Earth's resources, and increased operational flexibility for spacecraft operating in space, fostering a sustainable and economically viable space ecosystem. 2032. The cosmos becomes a construction site as in-orbit assembly techniques, which are methods for constructing structures such as space stations or habitats directly in space, revolutionize the development of large-scale space stations and habitats. This leads to the construction of modular structures that can be assembled piece by piece in space, lowering the logistical difficulties involved in launching pre-built structures and opening the door to the development of expensive habitats that can support human habitation for lengthy periods of time. These customizable configurations also allow for spacecraft to be tailored precisely to the unique requirements of each mission and payload. By employing standardized interfaces and interchangeable modules, spacecraft designers can rapidly assemble and reconfigure vessels to meet evolving scientific, commercial, and exploration objectives. 2033. Deployment of swarms of microsatellites for detailed mapping and monitoring of celestial bodies, enabling precise navigation and resource identification for future missions. These advanced microsatellites are equipped with cutting-edge sensors and imaging systems capable of capturing high-resolution data, facilitating precise navigation and comprehensive resource identification for forthcoming missions. Leveraging sophisticated onboard processing capabilities, these microsatellite swarms autonomously analyze data in real time, enabling rapid decision-making and enhancing mission efficiency. 2034. The initial testing of small-scale nuclear fusion propulsion systems. Tri-Alpha Energy and General Fusion collaborate with space agencies to develop compact fusion reactors capable of producing abundant, clean energy for spacecraft propulsion systems. These systems work by fusing light atomic nuclei to release vast amounts of energy, generating thrust on an unprecedented scale. These propulsion systems not only have reduced interplanetary transit times, but also increased payload capabilities and extended mission durations. These systems rely on isotopes of hydrogen, abundant in resources throughout the universe, as fuel sources and are therefore more sustainable. 2035. Mars colonization efforts intensify. During the perihelic opposition, when Mars is closest to the Earth in its orbit, SpaceX's Starship, equipped with advanced life support systems and radiation shielding, begins transporting settlers to Mars. Collaborative efforts between space agencies and private companies lead to the construction of Mars habitats using on-site resources that significantly reduce the cost and logistical challenges of colonization. Asteroid mining emerges as a viable and economically feasible industry, leveraging in situ resource utilization (ISRU) techniques. Spacefaring companies begin to deploy robotic spacecraft to near-Earth asteroids rich in precious metals and rare minerals. Advanced autonomous mining techniques are employed to extract resources, which are then transported back to Earth or used for in-space manufacturing. 2040. The launch of the first interstellar probes, propelled by fusion-powered engines. These probes, equipped with advanced sensors and communication systems, set out to explore nearby star systems and their exoplanets. Breakthrough initiatives like Breakthrough Starshot aim to send nanocrafts to Alpha Centauri at a fraction of the speed of light. 2042. With the deployment of autonomous spacecraft and maintenance drones, the cosmos becomes a self-sustaining ecosystem. Emerging from a collaboration between Northrop Grumman and the European Space Agency, these robotic assistants perform intricate repairs and inspections on orbiting spacecraft and infrastructure. They come equipped with advanced tools and guided by sophisticated AI algorithms, which enable them to conduct precise operations in the unforgiving environment of space and ensure the continued functionality and safety of critical space assets. 2045. Artificial intelligence takes center stage aboard spacecraft, completely revolutionizing navigation and control systems with unprecedented levels of autonomy, decision-making capabilities, and capacity to adapt to the rigors of long-duration missions across the solar system. The integration of AI algorithms into spacecraft avionics enhances reliability, safety, and autonomy in space missions. It also enables fault detection, autonomous navigation, adaptive control, predictive maintenance, and risk assessment, effectively reducing reliance on ground controls. 2046. Nanotechnology is integrated into spacecraft maintenance and repair at the molecular level. Nanobots equipped with advanced sensors and tools navigate spacecraft surfaces, identifying and repairing structural damages with unparalleled precision. These nanobots operate autonomously, executing intricate repair tasks without the need for human intervention, effectively eliminating the need for expensive and risky maintenance missions. Swarm intelligence algorithms for autonomous spacecraft coordination and collaboration are deployed, enabling complex missions with distributed decision-making capabilities. This is followed by the deployment of gravitational wave propulsion systems for efficient and low-energy interstellar travel, as well as the integration of virtual reality and telepresence technologies for immersive exploration and remote operation of robotic probes and rovers across planetary surfaces. 2047. Development of adaptive spacecraft skins capable of dynamically adjusting thermal properties and surface characteristics in response to changing environmental conditions. These skins incorporate smart materials and microfluidic channels that regulate heat exchange and surface morphology. As temperatures fluctuate or encounter varying levels of radiation, these skins automatically adjust, optimizing thermal insulation or dissipation and altering surface properties for enhanced protection or maneuverability. With such adaptive capabilities, optimal performance and durability of spacecraft across diverse mission profiles, from orbiting in extreme heat to traversing icy celestial bodies, is ensured. 2048. Self-healing materials and cutting-edge 3D printing technologies are integrated into spacecraft systems to enable in-situ repairs and component replacement. The former consists of materials that are designed to autonomously mend structural damages caused by micrometeoroid impacts and wear over time, while the latter allows for the on-demand fabrication of spare parts and intricate components directly aboard the spacecraft. 2049. Life support systems employing closed-loop recycling technologies are introduced alongside advanced synthetic biology techniques for onboard food production and recycling. These cutting-edge systems minimize the need for resupply missions by efficiently recycling air, water, and waste within confined spacecraft environments, achieving a synergistic integration of biological and mechanical processes that create regenerative ecosystems capable of supporting extended crew missions to distant celestial bodies. Quantum communication networks utilizing entangled photon pairs for secure information transfer safeguard space-based assets against cyber threats and interference. 2051. The pressing necessity for robust asteroid defense mechanisms become increasingly evident amidst the establishment of colonies on Earth, the Moon, and Mars. Innovative trials are currently underway, centering on the implementation of propulsion systems directly onto asteroids to facilitate controlled alterations in their trajectories. These groundbreaking initiatives signify a pivotal stride forward in fortifying our extraterrestrial settlements against the looming threat of catastrophic asteroid impacts, safeguarding the future of humanity's expansion into the cosmos. 2053. Spacecraft design incorporates gravitational manipulation technologies to mitigate the negative psychological consequences of extended weightlessness on crew members' health. Spacecraft can replicate gravity by integrating sophisticated gravitational field manipulation devices, which lowers the dangers involved in long-term space missions. Spacecraft are designed with rotating habitats where artificial gravity is produced by the centrifugal forces of rotation. These rotating habitats use centrifugal force to simulate the effects of gravity by revolving around a central axis in the form of concentric rings or modules. Gravitational manipulation devices are used by spacecraft to create localized gravitational fields within designated zones, which enables crew members to exercise and carry out duties in surroundings with different gravity levels. For crewed missions to distant exoplanets, hibernation and suspended animation technologies are developed to reduce metabolic demands. 2055. The advent of antimatter propulsion in interstellar ramjets. Antimatter propulsion harnesses matter-antimatter reactions for unparalleled thrust, enabling spacecraft to achieve significant fractions of the speed of light. Meanwhile, interstellar ramjets utilize magnetic fields to compress interstellar hydrogen as a propellant, propelling spacecraft to relativistic speeds and offering the tantalizing prospect of reaching distant stars within human lifetimes. 2065. Advanced radiation shielding materials and technologies are developed to protect spacecraft and crew from the hazards of deep space travel during long-duration missions beyond Earth's magnetosphere. Collaborative efforts between aerospace engineers, material scientists, and medical experts yield robust shielding solutions capable of deflecting and absorbing cosmic radiation with unprecedented efficiency. Innovative materials such as graphene-based composites and metamaterials are utilized as spacecraft designers seek ways to fortify vessel hulls against the relentless onslaught of cosmic rays, further ensuring the safety and well-being of crew members throughout extended voyages. 2071. The establishment of space-based manufacturing facilities transforms the production of materials and spacecraft components in orbit, turning the universe into a veritable industrial furnace. These orbital factories, driven by innovative firms, use in-situ resource utilization (ISRU) and advanced additive manufacturing processes to produce materials and complex structures with unmatched accuracy and productivity. Space-based manufacturing facilities significantly lower launch costs and logistical complexity, while simultaneously enhancing mission flexibility and scalability by removing the limitations imposed by Earth's gravity and atmosphere. 2075. The emergence of biometric designs, which draw inspiration from nature, brings about a fundamental change in spaceship engineering. These cutting-edge spaceship concepts maximize performance in harsh settings like vacuum and microgravity by taking inspiration from the adaptability and efficiency seen in biological creatures. Spacecraft can achieve increased structural integrity, simplified energy consumption, and superior aerodynamic profiles by mimicking the solutions found in nature. Biomimetic materials, which imitate the characteristics of natural materials, help spacecraft remain durable and adaptable in a hostile cosmic environment. 2080. The dream of rapid interstellar travel becomes a reality with the integration of advanced propulsion systems, including warp drives and wormhole generators, into spacecraft designs. Inspired by the theoretical frameworks of Alcubierre and Thorne, visionary researchers and engineers embark on a quest to harness the fabric of spacetime itself, bending it to their will in pursuit of cosmic exploration and colonization. Through innovative applications of exotic matter and energy, spacecraft equipped with warp drives and wormhole generators traverse the vast distances between stars in mere fractions of the time previously thought impossible. opening up a universe of possibilities for humanity's expansion into the cosmos. As the cosmic horizon beckons with newfound allure, humanity stands on the threshold of a new age of interstellar adventure, propelled by the boundless potential of advanced propulsion technologies. 2091. Advanced propulsion systems such as wormhole generators and warp motors are incorporated into spaceship architecture to enable fast interstellar travel. Motivated by novel theoretical frameworks developed by Alcubierre and Thorne, scientists and engineers set out to harness space-time itself and bend it to their will. Wormholes, which are hypothetical tunnels through space-time that connect distant points in the universe, are used to traverse vast distances in space almost instantaneously, effectively bypassing the limitations of propulsion methods. Warp drives compress space-time in front of a spacecraft while expanding it behind, and by doing so, it effectively creates a warp bubble that would allow the spacecraft to ride a wave of warped space-time. Within the warp bubble, the spacecraft itself would not be moving at speeds faster than light, but instead it would be carried along the expansion of space-time, allowing for FTL travel without violating Einstein's theory of relativity. Spacecraft fitted with warp drives and wormhole generators travel the vast distances between stars in a fraction of the time previously believed possible. 3100. With the development of fleets of self-replicating spaceships designed to proliferate independently and adjust to the difficulties of interstellar travel, the furthest reaches of the universe are within humanity's grasp. These self-replicating probes, equipped with highly advanced artificial intelligence and utilizing state-of-the-art nanotechnology, embark on autonomous exploration and colonization missions to far-off star systems. Each spaceship in the fleet is capable of replicating itself using raw materials found in space. The artificial intelligence systems on board these probes continuously adapt and optimize their navigation, propulsion, and resource utilization strategies, while the nanotechnology employed allows for precise manipulation of matter at the molecular level, facilitating efficient construction, repair, and adaptation of space components while en route to distant destinations. 3600. Quantum propulsion system developments further transform interstellar travel. These systems harness the principles of quantum entanglement, superposition, and tunneling for instantaneous propulsion. Quantum entanglement works by linking the states of particles regardless of distance, enabling instantaneous communication and propulsion across vast distances. This phenomena allows spacecraft to bypass the constraints of traditional propulsion methods, reliant on relativistic travel. Meanwhile, quantum tunneling exploits the ability of particles to penetrate energy barriers, facilitating rapid transit between distant star systems by navigating through space-time barriers. With quantum-enabled spacecraft networks spanning the galaxy, humanity is on the verge of colonizing the entire universe. 4000. Humanity has achieved the capability to explore parallel universes and alternate dimensions, facilitated by propulsion systems capable of manipulating space-time. Quantum sensors for detecting sensible phenomena across universes, hyperdimensional navigation systems for mapping higher dimensional spaces, and interdimensional communication technologies based on quantum entanglement. This represents the culmination of humanity's deep understanding of reality and the development of sophisticated spacefaring capabilities. What technological advancement are you most excited about for humanity's future in space? Do you have any predictions of your own regarding our destiny in space? Feel free to leave your answers in the comments below.